Today's lesson is about solving trig equations with the quadratic pattern. Let's go to part 5. Solve for x on the given domain. You have a cosine square x and cosine x. We know this is a quadratic pattern. For quadratic pattern, first of all, you will get equal to 0 form. Second step, try common factor. Third step, if common factor didn't work, you can do ninja x. Then solve. So for A, 0 equals 2 cosine square x plus cosine x. You already get equal 0 form. So we will check a common factor. We do have common factor cosine x. So we have 2 cosine x plus 1. We do know this formula A times B equal to 0. This means A equals 0 or B equals to 0. If A over B equal to 0, means A equal to 0. For example, if we have x plus 1 times 2x minus 1 equal to 0, you will set up x plus 1 equal to 0 or 2x minus 1 equal to 0. So we have x1 equals to -1 and x2 equals 1 over 2. If you solve this equation, x plus 1 over 2x minus 1 equal to 0, you will set up x plus 1 equal to 0 only, then x equals to -1. So you only have one solution to this equation. We have two solutions to this equation. Therefore, for this, you will set up cosine x equals to 0 or 2 cosine x plus 1 equal to 0. And for this one, you will get the cosine x equals to -1 over 2. We need a diagram. The diagram is in the closed interval from 0 to 2 pi. For cosine x equal to 0, this is a quadrantal angle, which means the angle is on x-axis or y-axis. Coordinate in this diagram is CST. The first coordinate is 0. It's here. This is here. Therefore, for x equals pi over 2 and 3 pi over 2. For cosine x equals -1 over 2, we need to get the reference angle. That is 60 equals pi over 3. Since this number is a negative, which means to go to second and third quadrant. So we got to use this one and this one. N equals 3. Therefore, your x equals 2 pi over 3 and 4 pi over 3. So you have 4 solutions to this equation. Let's go to D. 2 sine square x plus 3 sine x plus 1 equal to 0. We know this is a quadratic pattern. You need to get equal to 0 form. This is equal to 0. Therefore, you cannot have a common factor. So we need to go to ninja x. Ninja x, the pattern is this. For ax squared plus bx plus c, make sure a is a positive. So a times c. over A over A. Then this is a B. We will set up 1 times 2, that is 2, over 2 over 2. Then here's a 3. We know 2, we get the factor pairs. It's 1 times 2. You're adding is 3. So we get this. And reduce 1 over 1. The variable this time is not x, it's sin x. So sin x. Then you do bottom up. You will get sin x plus 1 times 2 sin x plus 1 equal to 0. Sin x plus 1 equal to 0, or 2 sin x plus 1 equal to 0. So sin x equals -1. This is the diagram we created for the previous question. For sin x equals to -1, which means the second coordinate equal to -1, then you could say here is a negative pi over 2. Give you -1. Therefore, x equals negative pi over 2. This is a linear pattern, so we need to isolate the variable on one side. You will get the sin x equals -1 over 2. Reference angle equals 30 degrees equals pi over 6. So sin x equals -1 over 2 will go to the third and fourth quadrant. We got to use this pattern and this pattern to write down the answer. N equals 6. Therefore, x equals -5 pi over 6 and negative pi over 6 will be the solution. So we have 3 solutions to this equation. Let's go to E. 2 sin square x equals 2 minus cosine x. X is greater than or equal to 0, less than or equal to 2 pi. This is a quadratic pattern. So try to get equal to 0. Before we do that, we make sure we have the same trig function. This is a sin square x. Here's a cosine x. Either you change sin square x into cosine square x or cosine x into sin x. We do know the trig identity sin square x plus cosine square x equals to 1. So for sin square x minus cosine square x both sides, you will get the sin square x equals 1 minus cosine square x. For cosine x, there's no way for you to change into sin x without changing the angle. Therefore, I will get the 2 parentheses 1 minus cosine square x equals 2 minus cosine x. Then distributive property, you will get the 2 minus 2 cosine square x equals 2 minus cosine x. Since this is a quadratic pattern, we need to move everything to one side so that we can get equal to 0 form. We will move everything to the right side because we want to make a leading coefficient is a positive. When I move -2 cosine square x from left side to the right side, I will get +2 cosine square x. Then minus cosine x plus 2 minus 2. Then combine like terms. You will get 2 cosine square x minus cosine x. Common factor. You will get the cosine x times 2 cosine x minus 1. So that you will get the cosine x equal to 0. And 2 cosine x minus 1 equal to 0. Cosine x equal to 1 over 2. We need a diagram for the closed interval from 0 to 2 pi. And from this diagram, cosine x equal to 0, we know the coordinate is CST. Since we are looking for the first coordinate is 0, so you get the pi over 2 and 3 pi over 2 will be your solution. So x equals pi over 2 and 3 pi over 2. For cosine x equals to 1 over 2, we need a reference angle. That is a 60 degree pi over 3. 1 over 2 is a positive, so go to first and then the fourth quadrant. So x equals first quadrant, it's a pi over 3. Fourth quadrant is this pattern. So you get 5 pi over 3. You have 4 solutions to this equation.